Hi guys. In this video, we're going to focus on the second part of the title for today, which is dividing rational expressions. And there's really kind of two different ways to approach a problem depending on what you can do in the problem. So we'll take a look at both of those. First, just like on a multiplication problem, you are allowed to take two separate radicals that are being divided and merge them into a single radical of a fraction. Or you could take a single fraction under a radical and you can separate it out into two separate radicals. The big idea here, though, is that they have to be the same type of radicals. So they have to have the same index. So notice my index on all of these is the letter n. Now, depending on the numbers underneath the radicals, sometimes it's better to treat it as two separate radicals, and sometimes it's better to treat it as one fraction under a radical. So let's talk about when it's appropriate to use each of those forms. Here is our first example. In this example, I was given two separate radicals. They're both square roots, so I could put them together if I want to. To decide if you want to put the radicals together, take a look at the numbers underneath the radicals. If those numbers can simplify, this is a fraction, this is dividing. If those numbers can divide, yeah, put them together, make them a fraction. Absolutely. So let's merge those together into a single fraction and let's simplify our fraction. So 50 divided by 2 is 25. X to the 6th divided by x to the 4th, you do subtraction, 6 minus 4 is x squared. And now I can do this. This is so much easier. Don't forget your absolute value bars. In this problem, we have even, even, odd. Let's review that really quickly. I have an even index. I have an even exponent, and I get an odd exponent in my answer. So I need to put absolute value bars around that letter x. Let's try one more where we can merge them together and simplify just to make sure we got it. If you want to, if you're feeling confident, go ahead and pause the video and try this one on your own. Otherwise, let's do this one together. So in this problem, again, we have two separate radicals. They're both cube roots. That's important. And I noticed that they both have a letter y, so that's promising. And 162, maybe it's divisible by 3. That's a quick check on your calculator, right? And it is. So let's take those two radicals and let's merge them together into a single radical of a fraction. And we're doing this because we know that that fraction will simplify. Feel confident it's going to simplify. So type in my calculator, 162 divided by 3. For my letter y's, I'm going to subtract. 5 minus 2 is y to the third. Now, with your 54, you should do a factor tree. 54 is not a perfect cube. It's not going to be something you can just write a single number for. So do your factor tree on 54. We're looking for 3 of a kind because it's a cube root. And it looks like I had 3 number 3s and the leftover number 2. My final answer to this problem is 3y and then the cube root of 2. Now notice that I didn't put the space in this one like I did in the first video, and it's almost a little bit confusing. That 3 is awfully close to that letter y. It might be a y to the third. So that's why we kind of want to get into the habit of spacing those out a little bit more to make sure that our exponent and our index don't get mixed up. Now, these were both problems where it was good for us to merge it into a single radical of a fraction, but sometimes we don't want that. Sometimes our fraction does not simplify, and that's when we want to keep it as two separate radicals. So let's take a look at those. So on our first two examples, it was beneficial for us to merge our radicals together because we knew that we were going to have a fraction that simplified. In this problem, I don't think my fraction is going to simplify, guys. I've got a 7 and a 5. Those are both prime. That's not going to reduce. I've got two different variables. Merging these together, that's not going to help me at all. So if your fraction cannot simplify, it's actually better to keep them as two separate radicals. Even though they have the same index, let's keep them separated. And you know what? Right now, I don't have three of a kind of anything. I've got prime numbers. My biggest exponent is a 2. It's looking like I can't really do anything with this problem. But there is a rule. Think of it like math grammar that says you can't have a radical on the bottom of a fraction. So even though I can't do any math right now with this, it's really bad that I have a cube root underneath the fraction bar. And then I need it to go away. I need it to be just regular normal numbers and variables under the fraction bar. So we're going to do a process called rationalizing the denominator. Rationalizing the denominator is a way to make all of your radicals disappear from just the bottom of the fraction. Now you can still have radicals on top, just not on the bottom. To make the radical from the bottom completely disappear, we need that 5 to get out, and we need that y to get out so that there's nothing left underneath. So the question we need to ask ourselves is, how many more 5s do I need so that I have enough 5s that they can escape? And how many more y's do I need so that I have enough y's that they can get out? So we are going to multiply the top and bottom by a cube root because we want to keep that index the same. And as long as you're multiplying the top and bottom of a fraction, it's totally legit. You can do it, right? Top and bottom by the same thing, we're good. And what we're going to do is we're going to multiply by as many 5s and y's as I need so that they can get out of that radical. Now, because this is a cube root, we need 3 of a kind for anything to get out. So right now I only have one number 5. So if I want 3, I'm going to need 2 more. So let's multiply by 2 more number 5s. Then I have 3. For my y's, I have a y squared, which means technically I have 2 letter y's right now. And I need 3 for him to get out. So let's throw another one in there. Now I've got 3 letter y's. We have to multiply the top and bottom by the same thing. So we're going to multiply the top also by 5, 5, and y. And it has to be that cube root because you can only multiply them together if they have the same index. Now, just for visual purposes, I'm going to put everything underneath the same radical on the top and the bottom. So on the top, I can see I still don't have 3 of a kind. I've got a 7 and 2 5s, and I have 2 different variables. So nothing can get out on the top. But now on the bottom, I have 3 number 5s, so they can get out of here. And I have a y to the third, which can also get out. And so from the bottom, and you got to keep this on the denominator, I can have just a 5y. And since nothing could get out from the top, I'm just going to multiply it all back together. 7 times 5 times 5 is 175. Please notice that my radical is completely above the fraction bar. It does not drop down below at all. So make sure you keep that radical above the fraction bar. And you have just regular numbers and letters on the bottom. This is my final grammatically correct answer to this problem. Let's try one more. If you're feeling confident, you want to try this on your own, go for it. Now, there are several different ways that you can do this problem. So I'm going to show you the way that I did it, which is the way that makes the most sense to me. And I feel like it's the fastest and maybe makes the least amount of mistakes, maybe. If you tried this a different way, as long as you got the same answer as me, we're good. And we can always discuss this during our live session. So what I did first, I noticed that my fraction was not going to simplify, so I separated out my radicals. 5 and 8 does not reduce, so might as well make it 2 separate square roots. The next thing that I did, I thought would be the most helpful to me, actually factor treed my 8. So in the problem, the first example, both the numbers were prime, so I didn't really need to factor tree. But if you can factor tree the 8 and get some of those numbers out right now, like let's do it. So 8 becomes 3 number 2s. I didn't factor tree the 5 because 5 is prime, so I don't need to factor tree it. I do see this is square roots. I'm looking for pairs. I do see a pair of 2s in there. So I am going to circle my 2 2s and one gets out. The other one's poof, gone. And then the 2 and the X, the third 2, right, and the X, those have to stay inside. So now I've done as much simplifying as I can. I've still got that square root underneath the fraction bar. That's no good. I need to get rid of it. So this is where we start rationalizing our denominator. Since this is a square root problem, I only need two of a kind for it to get out. And I've already got one of each. So as long as I put one more of each into the problem, I should be able to get rid of that radical on the bottom. Now, at this point in time, you can probably write your final answer, but if you are a visual person, maybe you want to put everything underneath the same radical, then you can see very clearly we have two number twos, we have two letter X's. When those get out, they have to stay underneath the fraction bar, and they're going to multiply with the two that was already out there. On top, nothing can get out, and so the top will stay a square root of 10x. This is my final answer for this question. And this is the end of our second video for today.